All right, everybody, we've got another triangle to look at, another one of those non-right triangles. And let's see, we'll set up that C is 15 degrees, which means that this is 6, and this can be 10, which means that this is angle A, and then this would be angle B and side B. Okay, so remember, law of sines requires that we have an angle and the side opposite that angle, which we have in 15 degrees and the side length 6. So we're going to just set this up as 6 over the sine of 15 is equal to, let's say, 10 over sine A. And if you remember from the last video, I want to set this up one more time for you just to remind you that it's better, I think, to have the variable in the numerator. So it'd probably be more beneficial to us to set this up as sine 15 over 6 is equal to the sine of A over 10. Okay, and if I multiply both sides by 10, then I've got the sine of A is equal to, looks like 10 times sine 15 over 6. And then if you recall from a previous triangle that we solved, I'm going to have to take the sine inverse of both sides. And I'm just going to do that sort of up front here so that I can say A is equal to the sine inverse of whatever this fraction is that I'm going to put into the calculator. So 10 times sine 15 over 6. So I'll just take 10 times the sine of 15 over 6. And just 1/6 there. There we go. So I get that ratio. And I know I'm going to have to take the sine inverse, so I'll go trig, sine inverse, go ahead up one level and grab that and hit enter. And I get 25.6 degrees, we'll say. Okay, 25.6. And let's see, there we go. So it turns out that angle A is 25.6 degrees. But remember, like we talked about in the last segment there, I've got to figure out what is that second quadrant reference angle that would give me the same sine ratio as 25.6. And what we remember is that if this is 25.6 degrees, then this angle measure here is 25.6 away from 180. So 180 minus 25.6 is going to be 154.4. I just did that in my head, and sometimes that can be a dangerous thing. I think that's right. So 154.4 degrees. So what I want to do is I'm going to get rid of these calculations here, and I want to check, just like I did in the last segment, to see if 154.4 degrees would work. Because in the last triangle it didn't, so we're kind of skeptical about this one, right? And here we've got this second triangle would be 15 degrees, and I guess I should draw it probably a little bit different since this is going to be a bigger angle. And remember, this is not drawn to scale at all, but it kind of represents the other situation that we have. This is still 10, this is still 6, and this angle measure would be 154.4. And what I want to do is I want to see if I can calculate this angle B then, and that would be side B. What would that angle B be in this second triangle? So it's going to be 180, take away 15, take away 154.4. And it turns out it's 10.6, so that actually leaves room for this angle to be 10.6 degrees, which is exactly what we looked at in that previous video, where we've got that side right there is in both positions, or can be placed in both positions to create two different triangles. So what we're going to do is go back here. Now I've got to solve both triangles. Okay, so it won't be too bad for this this first triangle that I dealt with. Here in the top right, I've got 15 plus 25.6 makes 40.6, which that would leave 139.4 degrees for angle B. Okay, yeah, 40 point, yeah, that looks right. And the way that I got that, again, is to find angle B, I'm just going to take 180 minus 15 minus 25.6 to come up with 139.4. So see, now that I have both triangles, if you look at both, the only thing that I'm missing in both is side B. So I'm just going to pick one of these triangles and set up the solution for side B. And let's go with this second triangle that I found. So to solve side B, it's going to be B over the sine of 10.6 degrees is equal to, and we'll just pick 6 over the sine of 15. So let's rewrite that 6 because that looked a little funky. Okay? And if I solve that, that's going to be B is equal to 6 times the sine of 10.6 over the sine of 15 degrees. Okay, so we'll put that in the calculator. 6 times sine of 10.6 divided by the sine of 15 degrees. And I get that the side length B in this particular triangle is 4.26. So here, in this triangle, I'll replace that with 4.26 approximately. And now that triangle is solved, right? I've got all three angles and all three sides. However, the original triangle that I set up with the angle A being 25.6 degrees, I've still got to find this side B. Now, if we set this up, I think this is going to look familiar. It's going to be B over the sine of 139.4 is equal to, should be 6 over sine 15 degrees. Okay, and if I solve this, just like I did previously, it'll be B is equal to 6 times, 6 times, oh geez. One more time for good luck. Sine 139, this is ridiculous, 139.4 over sine 15. And that looks really familiar because that looks exactly like this other equation that we set up right here. And lucky for us, it's already in the calculator. I'm just going to go back, grab it, and change that angle measure to 139.4. So I'll go back, grab this, change the angle measure to 139.4, and we'll hit enter, and that gives us 15.09. So if I go back here, the first triangle that I set up, we can replace B with 15.09. Okay, so in this case, setting up that second triangle with that second quadrant angle actually worked because it provided us with enough room to get that third angle B.